Those of you at home, we're doing page 110, question 3. We're doing 3 questions from the mixed exercise, so you might want to pause at this point and have a go at question 3 first. Actually, I put all 4 reasons you need to use binomial. It actually only asks for 1, so any one of those 4. I guess in the context, though, of the problem, so fixed number of cars tested, successful and fail criteria in this case is that they're either passing or failing the brake test. The probability of a car failing we're assuming is constant, and if this car fails, that in no way affects whether or not this car fails. Brake failure is not contagious. Those are the 4 things that we need for binomial. So this is quite a nice question because part B is just a common or garden vanilla binomial problem. We've tested 5 cars and we want to know the probability of just 5. And remember, I encourage you to use binomial cumulative all the time, and that just means you need to type upper and lower as 5. And so that should have given you this tiny probability, 0.00243, which we round to 4 decimal places, so that's that one. But then it goes into a hypothesis testing question. And so the first question you need to ask yourself with hypothesis testing is this a one-tail or a two-tailed test? Our null hypothesis is that the probability of a car failing its brake test is 0.3. And you've just got to hunt in the wording. What are you going to tell me?
Wouldn't the answer be them failing?
This is car.
Oh!
Yeah.
Thank you very much. I really need to get some biscuits, don't I? There you go. Yeah. So if they all pass, that's 0 failed, isn't it? Thank you very much, Max, and thank you, James. Yeah. So that's 0, 0. I apologise. There we go. 0 point wasn't quite as vanilla as I suggested. There you go. I got caught out by my passing and my failing. Anyway, so going back to this part C, you've just got to hunt for. Are they believing that the probability is bigger, smaller, or just different? Bigger or smaller, one-tailed test. Different, two-tailed test. Go on, Ben. Are we looking for evidence that the chance of failing is more, less, or just different? In the question, and it's going to be hidden in part C.
Less.
It's less. It says less than the national average. So in this case, we're breathing a sigh of relief, really, because two-tailed tests are a bit of a faff, aren't they? So yeah, we think the probability that it fails is 0.03. Now I need to get it right. Okay, I've done it right because 2 fail the test. So they do a sample of 10, and we're looking for the probability that 2 fail the test, although when we're doing hypothesis testing, we actually test 0 to 2, or if we're at the top end, that number to 10. So my probability of 0 to 2 comes out at 0.38 something. 0, so it's probability that 0.3828, which is less than 5%. Sorry, it's been a long day, which is more than 5%, more than 5%. And that means we haven't got enough evidence to suggest that the probability's gone down. Okay, it may have done. It may have done. 2 is less than we expect, which is 10 times 0.33, but we don't have enough evidence. And this is this frustrating thing about hypothesis testing, it never really offers you a sort of definitive answer. But there we go, that's that one. Right, I'm going to go through 4 in a minute. If you get through number 4, have a go at number 6, I'll just show you the answer to that one. But my encouragement, once you finish the homework for this week, is that you have a look at the rest of mixed exercise 7. I know certainly those of you who committed to mixed exercise 6 found that you were, struggling with some problems that weren't worth struggling with. Okay, so for the first part of 4, this is a two-tailed test. We're actually just told that in the question, so we haven't actually got hypotheses here at all. We there's nothing saying they want to test that the number of defective articles, the probability of defective articles has changed. They're just saying it's a two-tailed test. But because it's a two-tailed test, we have to divide 5% by 2. So we're trying to get a probability close to 2.5. Now, in the default setting, we would pick the first value that dropped below 2.5%. So in a default question, the critical value at the bottom end would be 0. So if we found that 0 articles were defective, we would be suspicious, and the at the top end it would be 10, so it would be 0 to 10. But we've got this extra little bit of wording that we talked about yesterday. The probability in each tail should be as near to 2.5% as possible. Well, as being the first value that goes inside, 10 is the closest to 0.025. Couldn't get much closer. But this is actually, although it's bigger than 2.5%, 0.025, it is closer to 0.025 than that one. So because they've got that extra sentence, the probability in each tail should be as near as possible, the critical value in this case is 1. So the critical value is 1, and the critical region is x is less than or equal to 1. And can I modify the way I answered the top end? I think I'm okay saying x is greater than or equal to 10, but actually 50 is the maximum, and I did see that in the answers somewhere, that it's probably better, rather than writing x is bigger than 10, bigger than or equal to 10, to say 10 to 50. Obviously, if you're testing 50 cars, you can't get more than 50, so I suspect that you'd be okay if you just said x is greater than 10. The actual significance test, it's not 5%, because this and this don't add up to 5%. They add up to, he said being very lazy, 0.0583. Do they? 0.05? Yes, that seems to work. So actually the significance level is 5.83%. And do you remember yesterday, in fact, if you flick over to the back, if you're looking at the sheet we worked on yesterday, if you had got towards the bottom of that sheet, you've got questions that said the same thing. For example, question 7 in yesterday's work. But question 8 asked the same thing in a different way. State the probability of incorrectly rejecting H0 using this critical region. I'll come to it after. What we're saying is that probabilities in this region, we're going to say, right, something must have changed. But actually, it may not have changed. It may just be really, really unlikely. So when it says, state the probability of incorrectly rejecting the null hypothesis, that's the same answer. It's the same as saying, what's the actual significance level? So the actual significance level and the probability of incorrectly rejecting H0, they are the same thing. They are the same thing. Sorry, Arthur, your question.
I was going to ask, why wouldn't that be double what 0.0338 is? Because then it's not even either side. The two-tailed test.
Well, because we are going to reject any values in either that region or that region. It's a two-tailed test, so we're not sure whether it's bigger or smaller. So it's any value in that region, which has a probability of that, and in that region, which has a probability of that. So it's not double that, and it's not double that. It's those two added together.
Okay.
It is hard to get your head around this. I absolutely understand. Part C goes on to a normal hypothesis test question. So here we're now testing 20 articles, and this time it's a one-tailed test because we're asked, is there evidence that the proportion of defective articles has increased? So we're asking, is it bigger? 4 is bigger than the peak, which comes at 2, so we're looking at the top end. And, well, you get 0.133, I don't know why they've rounded it to 3 decimal places, but that's bigger than 10%, bigger than 0.1. So again, no evidence to support a change. Yes, Anne?
Why is it sometimes no evidence and sometimes no?
Same thing. Just two ways of saying the same thing. Yes, yes. No evidence is. Yeah, I think not enough is a better way of saying it, because something's fishy. 4 is more than we would expect. But yes, so I'd say not enough. But you're not going to lose marks over sort of little things like that. And if you got onto question 6, I'm not going to go to question 6 now, but there are the solutions if you got onto that. These 3 questions are from mixed exercise 7, and I would encourage you, I know I've set you a homework for this week, so make that your first priority, but I would encourage you to delve into mixed exercise 7 in the week ahead, because it's worth doing it. And it looks like, although I'll be here, it looks like we will be missing potentially a lesson on Thursday again because of more industrial action. So I want you to have plenty to get on with. But actually, that brings us to the end of statistics. It's not quite true. We didn't do any probability, and that's because probability is best done in year 2. However, a number of you are going to be taking the AS exam, so we're going to adopt a sort of two-tier approach, and I will do some probability with some people. But yeah, we've drawn a line under stats, and we're not far off drawing a line under mechanics. But we're going to return now and finish off pure. 2 more topics to cover, and then having finished off pure, we can finish mechanics. And my aim is to get through as much as possible by Easter, because for those taking AS, that gives plenty of time to revise. And then after half term, in the summer term, year 2, we get a half a term of year 2 under our belts, which just makes things so much better in the year ahead. So I'm going to get a couple of smart notebooks from the board to start with. We're not getting our smart notebooks. I'm going to start by talking again about differentiation. Okay? So, why is that not working? Right. So, can I just give you some y equals statements and ask you to differentiate them for me. So we're going back to pure. I'm not telling you what we're doing at the moment, except we're just doing a little recap of differentiation. So y equals, could you differentiate that for me? Sorry, my 5s appear to have turned into S's, and I don't know why. So there's 5 things for you to differentiate there for me. I'm hoping the first 2 you're going to rewrite them using index notation, replacing 1 over and the square root of with x to the power of something, because remember, you can't differentiate until you've done that. Okay, so I have, for my first 2, rewritten them using index notation, because I can't differentiate 1 over x until I've rewritten it as x to the minus 1. Then I can do multiply by the power, reduce the power by 1. Similarly, I can't differentiate the square root of x until I've written it as x to the half. So that first one becomes 4x, sorry, like an x. 4x minus x to the power of minus 2, and that's probably best rewritten as minus 1 over x squared. That's what x to the minus 2 means. The second one becomes 3 over 2 x to the minus a half. I'll come back to that in a minute. Minus 10x. Now that There's a whole lot going on here, isn't there? I'm going to write it as one big fraction. I've got 3 on the top and 2 on the bottom. X to the half is the square root of x, so x to the minus a half is 1 over the square root of x, so that's that. So that's 3 over 2 root x. And then the last 3 highlight a problem we have with where we're going to next, because all of them have the same answer. When you differentiate all 3 of those expressions, you get dy by dx as 10x. And that's all well and good, that's not a problem, unless we want to reverse the process. And we certainly do want to reverse the process, because the reverse process differentiation has 2 very key important applications, which we'll talk about in subsequent lessons. But this process is called differentiation. But what I'm interested in is the reverse process, and the reverse process we call integration. And so what we're going to be doing for the next few lessons is we're going to be meeting and using the reverse process of differentiation, which is called integration. We're not going to talk about any of its uses today, we're just going to practice the nuts and bolts of integration. So integration is the process that takes a dy by dx, or an f dash of x, a formula for the gradient, and turns it back into a y equals function. There is some other notation that we'll meet. But let me remind you how we differentiate it. We multiplied by the power and reduced the power by 1. That's how we differentiate. So I'm hoping that as intelligent mathematicians you can see how we do the reverse process. We undo what gets done. We increase the power by 1. And then we divide by the new power. So that is the process of integration. It undoes what's been done. We increase the power by 1 and divide by the new power. Differentiation, multiplied by the power, reduce the power by 1. Integration does the reverse. And so an expression like the one we've already met there, dy by dx is 10x, I know that I need to increase the power by 1, so 10x becomes 10x squared, and divide by the new power, which is 2. 10x squared divided by 2 is 5x squared. But we have a problem, and that problem is I don't know if the original function, the original y equals statement, had a constant term as well. It might not have done. It might just have been 5x squared, which gave us 10x. So when you integrate 10x, you get 5x squared. But there might have been a plus 2, or a minus 7, or a plus or minus an infinite number of different values. I don't know, because when you differentiate, those numbers get lost. So how do we deal with that? Well, we do what mathematicians love to do, we cheat. we just say it's going to be that potentially plus something. So we use C for that something. That something might be nothing, but it might be something. So we put it as a something. We call that our constant, and some people are very bad at forgetting to write their plus C when they integrate. Do you know how I know this? Because I am the worst. So you can. When I get some biscuits, I'll be giving out biscuits for people that can spot me missing out my plus C's. Now, that's unsatisfactory, isn't it? It's unsatisfactory just to say we don't know if there was something there. So we do have a couple of ways round it, which we'll meet not today, but in subsequent lessons. So for today, we're just going to leave it like that. So let's practice this new and wonderful skill called integration. If in the books you turn to page 288, and 289 even, page 289. And we're going to jump straight in at the deep end. So the first thing to note is that in this question, everything is already in index form. So there are no square roots or 1/overs. It's all the nasty stuff has been done for us. And that's a key point, that just like when you differentiate, you need to write things in index form first. When you integrate, you need to do the same. They've done that for us. So I'm going to do A, and then you can have a go at doing the others. So dy by dx in A is x cubed minus 3/2 x to the minus a half minus 6x to the minus 2. Okay. So I'm going to go through my process. Increase the power by 1, divide by the new power. Now, I'm not sure what the book does, but I need you to be happy that that is the same as that. And to be honest, I forget which way around the book writes it, but these two things mean the same. I'm a big fan of this, but they're the same thing. They're the same thing. Okay, this one's a bit nastier. The first thing I'll tell you is that coefficients, so numbers in front, they pass through unchanged, okay? It's like peanuts and sweet corn. They pass through completely unchanged. Don't think about it too much. So the minus 3/2, I'm going to write that down first, okay? So that minus 3/2, I'm going to write that down first. Then I'm going to look at my x term. I'm going to increase the power by 1. 1 bigger than minus a half is... And then I'm going to divide by the new power. Now, what on earth is going on here? Well, let's think about this slightly differently, okay? Why don't I say, okay, I'm going to think of this as a fraction, this answer. So let me just rewind slightly. I know I've got a fraction here, so I know my answer is going to be a fraction. The 3/2 is going to be there. X to the power of minus a half becomes x to the half. And then I divide by the new power. Well, if I divide by 3 and then divide by 4, that's the same as dividing by 3 times 4. So if I divide by 2, which I've already done, and divide by a half, that's the same as dividing by 2 times a half. And that's a bit nicer, isn't it? That's a bit nicer. Because actually that just ends up with minus 3x to the half divided by 1, which is just minus 3x to the half. So that simplifies to just minus 3x to the half. So that one didn't really need simplifying. That one did. Of course, your calculator would help you with that. You can't type in the x, but if you typed in, 3 over 2 times a half, or 3 divided by 2 divided by half to get the same answer. And then this one here, I've got -6, write that down first, passes through unchanged, increase the power by 1, divide by the new power. Remember, 1 bigger than -2 isn't -3, it's -1. And that's good news, isn't it? Because I'm dividing a negative by a negative, so that's going to become positive. And dividing by 1 is just the same answer, isn't it? Same. Because my original question was in index form, I don't feel the need to rewrite that as root x or as 1 over x. Have a go with some of those other ones there. See if you can make some progress in the few minutes we have left. Sorry, I've just realised I forgot plus C on the last example, so there you go. Biscuits all round. Not that I've got any. Time is against us. Just to sort out B then. So the 4's cancel out. Dividing by a third, remember the 3 pops to the top? We talked about that, I think, haven't we? So that's 3x to the third, not to minus third to the third. And then minus divided by minus is plus, so that's plus x to the minus 1 plus c. More of this next week. Lots more of this next week.